For the lunch keynote, we've got a very special speaker here. Some of you might think that C# is pretty crucial to Umbraco and what we do at Umbraco. And we'd be hard-pressed to find someone with more knowledge and experience with C# than today's keynote speaker. Please give a big round of applause to lead designer on the C# programming language, Torgersen.
The longer you go, the less work for me. So thank you very much. That was a warm welcome. I'm curious, I'm told that a lot of you use C#, probably not all of you. Can we just get a show of hands how many people use C# in their work? Okay, well, I'd say. Well, it's 50-50, roughly, so that's good. Assuming you raised both hands. This is my intro slide. What I'm going to do today is, so over the pandemic, it was time to reflect, what do I need in my life? What can I let go of? I let go of slides. So, there might be, I haven't sworn them off, but today I didn't bring any. Because I figured with slides it's easy to explain something super clearly, but it kind of just flies across the screen, and it's actually not so clear when you're not the one presenting it. And so I decided if we go at the speed of coding, especially my speed of coding, then hopefully, hopefully we'll get every detail as much as we want to. So we have about 45 minutes together, and I know there are people watching online as well. I do want to say one downside of doing this in code is that the code changes. And so if you have a question about a particular line of code and you save it for the Q&A in an hour, then that code will not exist anymore. So I'm happy to take a few questions. I realize that we're time constrained, but a few questions along the way is fine. I'll make sure to keep us on track to go through what I have. I'll try to make sure at least. I don't know you that well, so you might get me off track. So what I'm going to do is I'm just going to show you some of the stuff that is coming up in the next C#, because nowadays there's one every year. And you might all have heard that Umbraco embraces C# 10. That felt good for about 24 hours, and now I'm here to tell you, C# 11 is waiting in the wings. So it'll come out in November along with .NET 7. It's always been confusing with the version numbers between .NET and C#. Now they're not the same, but there's a simple formula, add 4 to the .NET version number and it'll be the C# number for the foreseeable future until we come up with something else. So speaking of adding numbers, here's some C# code that would almost have worked in C# 1, apart from being in a top-level statement and having var and all that. But, essentially, it's a numeric algorithm, right? It's the simplest possible numeric algorithm. You get an array of ints. We pass an array of ints. We get it here. We zoom around and accumulate the ints using plus and return the result. Okay, standard fare. But you get much beyond this kind of this level of abstraction, then C# kind of starts to really suck, which means if you want to abstract your numeric algorithms over multiple different numeric types, you're in for just a world of hurt in C#. There's no way to abstract over things that have a plus, things that have a 0, that kind of stuff. We just don't have a mechanism for it, and so the language really fails you there. It fails library authors and fails everyone who wants to write something a little more abstract, where the numeric data type isn't fixed. And you see a lot of copy-paste. You see a lot of overloads in system.math, because of that. So we felt, okay, nowadays, we're not shy about changing the .NET runtime to allow new features the way we used to be. It's still very expensive, but at least it's not impossible anymore. So like, okay, now's the time to fix this. Now's the time to deal with this. So let's actually generify this method here. Let's just make it generic. That's what you always wanted, right? You wanted it to be able to just take a t for the element type here and just, you know, do plus and 0 and whatnot on the t's. I think I've got them all the ints. That's what you'd like to do, I think. Would you like to do that? You know, if you're doing math, you'd probably like to do that. So it'd be great if there was just some interface that says, I'm a number, you know, number of t. What am I not? What is totally wrong here? Oh, when t is, where? Oh my God, I don't know my own language. I was cursed by that introduction there. Number of t. Oh my God, something went totally off script here. It's just running through this at home, at the hotel. Okay, a number of t. Did I somehow? Hang on a second. Done at 7.0. Preview, language and preview, enable. Okay. That was a big flop right there in the middle of the keynote. My number of t. Why isn't it there? Oh, okay. There we go. See, I'm running on an internal preview, and I did see the email last week that we're merging the change to move iNumber and the other interfaces into system.numerics. But of course, I updated the internal preview to where it actually happened last night. So that's the danger you get. Okay, so back to this being truly magic, I assure you. I am now T is now implementing this new interface that is in the .NET framework, now in system.numerics. And what you see is that some of the red squiggles went away. Well, one of the two red squiggles went away. Somehow, plus works on t's now. Okay. Now, 0 really is a number. It's an int. But maybe, you know, maybe we can walk up to the type parameter. Since operators are static members, maybe if I can look for other static members. And here's something called additive identity. That sounds good. Sounds like the kind of thing that you'd want. And now all of a sudden, I have a fully generic method that compiles and therefore, in the nature of things, totally works. And if you look at we'll run it in a minute. If you look at the call here, you know, there's an int array coming in, inferred from its element types, and therefore we infer int as a type argument. Presumably int is some kind of number, and therefore it all goes. Let's run it, you know. I'm feeling lucky, given how it started out. And, you know, it works. It adds them up, just like it did before. But if you take one of them and change it to a double, then the others convert to double, and we infer array of double, and therefore the inferred type argument is double, and still we see no errors. And if we run it, it's adding them using doubles plus. Okay? So we've abstracted over at least two things, plus and 0. And the question is, what's going on? You know, what's happening here? How is this working? What is the magic? So why don't we go and have a look? So let's go to iNumber and look at the declaration of it. Now that I've found it, and what we see immediately is there's some really weird stuff inside here that didn't exist before. There are static abstract members. Okay. Interfaces can now have static abstract members. So what does that mean? Oh, a little applause there, that's good. You're like, was that the punchline? Is there going to be another one? Not sure. So interfaces can have static abstract members, and what that means is that if you implement that interface, you better have a static member that satisfies that abstract declaration. Okay, you need to implement that interface member, and you do that with a static declaration. And static members, of course, can be all kinds of like static methods and static properties, but it can also, and we're not seeing that here, but one kind of static members is operators. And this means we can now have interfaces that declare virtual operators that can then be implemented by the implementing classes or structs. Let's have a look at plus, for instance. So you see, other than these things in number, these are kind of actually the more obscure ones, it implements a whole host of interfaces. You can see how big, how small the scroll bar is here and how far we can go. Look at all the interfaces iNumber implements. It is sort of the, it's the nexus where all these different, a bunch of different numeric interfaces come together, each of which just represents one or a couple of different capabilities, numeric capabilities. So here's additive identity. That's probably the one that brought in the additive identity property from before. Here's all kinds of operators, but addition operator is right near the beginning somewhere. You see it? Addition operator. There it is. There it is. That's one of the interfaces it implements. And let's just go on a wild guess here that it's the one that implements addition operators. Let's have a look. It does. It does. It actually, it's quite general. It takes 3 type parameters, and one of them is called tself, and we'll get back to that in a minute. So, but essentially, tself and tother are the 2 operand types, and tresult is the result type. So it's fully abstracted, right? You can add any kind of thing and get any kind of thing out. There's 2 plus operators because another little C# 11 addition is that we allow you to declare checked operators. So that there's checked and unchecked context. Most people don't care about this, but for math, all the built-in math, you can put it in a checked context and then it'll throw instead of overflow. Well, we made that abstracted also, so you can declare, if you declare both an ordinary operator plus and a checked operator plus, then the checked will kick in whenever you're in a checked context instead of the other one. So that's another little addition we did. But the main thing here is we are declaring abstract, virtual, plus operators here in an interface. So it's fully abstracted. And that's the engine behind this. We decided to add the language feature of static abstracts, and then also this whole set of interfaces, this library essentially modeling all the numeric capabilities that our own number types have, and then our own number types implement all these interfaces accordingly. Like int will implement iNumber because it has all the number. It can do everything that a number can do. If you think about datetime, for instance, it's not fully a number. You can't add a datetime to itself, for instance. But datetime will implement some of this. It will have a version of iAddition operators where tself is datetime and tother is time span. Right? So that's an example of where you'd want to break down which interfaces you implement, but still get the level of abstraction you want there. So we implement those, and you can abstract over all our numeric types and quasi-numeric, like datetime. But also, of course, you can, if you're implementing your own numeric types, you can also implement these interfaces and plug into the same numeric algorithms. A good example is if you're implementing a matrix type. A matrix isn't just a table, right? A matrix is a mathematical object that supports plus addition and multiplication, and you can now give it you can define your matrix type generically with a T that's the element type, constrained to being something that has addition and multiplication and 0. You may need 1 as well. And whatever you need in order to implement the matrix level math, like the matrix multiplication and addition and so on, the cross product, all that stuff. And now you have a completely generic implementation of a data structure, just like you can with algorithms. So that's like sort of the motivating scenario, and that's why we put all these interfaces in. But we don't think of static abstracts as just a math feature in C#. It's really like a very general abstraction mechanism. And one way to realize this is, let's actually go back to, the, not that one, but to iNumber, and have a look here. One of the interfaces that iNumber implements is interesting, and let's go and have a look at it. And that's one called iParsable. I think they're roughly in alphabetical order here. They moved them around as well. Where is it? iParsable, there it is. Just last week, I promise you they were in alphabetical order. Now they clean them up so they're grouped by theme or some fancy like that. But, oh well. Navigating to definition. Okay, look at iParsable. It's a little gnarly because, so static abstract members, again, there's an iFormat provider to tell you exactly how the formatting is and how to deal with that. But the core of the matter is, there are two static methods here that are about parsing to the type that this interface is implemented on, okay? So you can't have them be instance members. You can't, because the instance isn't there yet. The value isn't there yet. What you want is a type-specific way of parsing from a string to whatever implements parsable. Well, that's a factory, right? It's a factory. It's something that takes input and creates a value of a given type. It's a static factory in that it lives as a static member on the type. And you know static factories. You can have them in your own type, and that's great. But it's also an abstract factory, meaning that every type can implement its own version of it. So static factory and abstract factory, these two design patterns, they marry here, and this is both. And what that means is that if you have this, like some of you might get into this very gnarly business with, if you want to abstract over creation, you have like a separate hierarchy of factory types that are only there so that you can abstract over the creation of their corresponding types in the real hierarchy. Well, now you can get rid of that. You can just have your static abstract factories, in an interface and abstract over that. The last thing I want to point out here is this T-self type parameter that's there. The thing is, we don't want methods like parse here to just return iParsable, right? Then you've lost. You might create, your type, but what you get back is only statically typed as the interface. So we need to be able to, abstract the interface itself over the concrete type that it's trading in. And you saw that with the other members as well, or the other types. They typically have a T-self. It's nothing in the language feature forces it, but it's typically useful that you abstract over what is the concrete class that is eventually implementing me, so that when you describe these static operations, you can say my input should be the concrete thing. I can't take any I addition operator thing. I can only take the one that I'm implemented on, and I only return the one I'm implemented on. So in order to create that, you need to take a type parameter representing the concrete type. And that's what we call T-self in these interfaces. I hope that makes sense. It makes it a little more gnarly when you use it, like here, because you have to sort of close the recursion and say, I'm not just an I number, I'm an I number of T. And when you implement it concretely, where int implemented, it will say, I'm an I number of int. I'm an I number where plus operates over ints. Make sense? Okay. So I spent a lot of time on this, but this is the biggest feature of C# 11. Like this changes, this is a new abstraction mechanism. When was the last time we added a whole new abstraction mechanism to C#? I think that was generics in 2005. So it's okay to spend a little time on, and I hope it's going to be really useful for you. And I hope one of the things when you do something like this is it's a really big hammer, and people will use it for all kinds of things that we haven't thought about. And I really look forward to seeing, what design patterns get simplified, what new structures, new architectures, new ways of structuring your code become possible, hopefully simpler than the alternatives you have today with this feature. So if you think of something, shoot me an email. I'm really curious to see how this all goes. Okay. So that was the first one. Any questions? Yes, one on the front row.
In your interface, you've got it listed as static abstract. What is the abstract doing?
In the interface, it says static abstract. When you have an instance member in an interface, you don't have to say abstract. But unfortunately, we didn't have as much foresight as, we didn't anticipate this feature. And so you can already today declare static members in interfaces. And they're not abstract. And so we need to make you say it. And we regret that a little bit, but it is what it is. We can't go breaking that. So that's why we force you to say abstract with the static members. that doesn't work yet in this preview, but we also, like we added default implementations to interface members a couple of releases ago, you can also have that with the static ones. You can, let's say you have an equals and a not equals abstract operator, you might want to provide a default implementation for the not equals that just calls equals and does not. So, you know, we'll do that kind of thing, and that also works. And when you do that, you say virtual because you're providing a body. So just like with classes. Okay. Let's move on to the next thing. Yeah? Good. So back to our little program. Now, nice program, very imperative. Over the last 4 major releases of C#, we've been gradually rolling out more and more pattern matching. Pattern matching is a more declarative way of having control structure. You match some pattern. If the pattern matches, it might extract some information into variables, and if the pattern matched, you can then use those variables to do something or call something. That's great. One thing we didn't do with pattern matching yet, though, is to deal with list-like structures, collections. We want to put more of an emphasis on collections in the coming releases of C#, and this is sort of our first push on that. So what does it look like to do pattern matching? Let's implement this one with pattern matching and what we call list patterns, the new kind of pattern. So doing pattern matching, essentially, let's do it as a expression-bodied members. It's very functional, very like functional languages. And I may be exaggerating that a little bit in this. You don't have to do it like that. It's just, some people complain less if you throw them a bone once in a while. So if I take values, then I can switch on it with a switch expression. And let's get this on a separate line here. And in the switch expression, I can now add cases. There's like a switch statement, if you recall, but just with different syntax. Less of it. So switch, it's complaining that I don't actually handle anything. The pattern anything is not covered. Okay. Well, let's add some patterns. So what we want to essentially, let's implement this recursively. So let's say if the list is empty, let's just return whatever 0 this thing has, this t dot, I don't know why it wants, there's additive identity. It actually has there's actually a 0 as well on number, which is both like multiplicative, whatever that is. It's not a neutral, I don't know what you call it, when the zero that will just become 0. Anyway, this is both of those. But anyway, it's a shorter way of saying 0. And if you have something, let's say you have one thing, we can put a recursive pattern in here to deal with that something. So let's say var t, and if we get a list with a single element, we call it t, and then it makes sense to just return the t, because that's the sum of one thing. The two things, we could say var t1 and var t2. We could also put other patterns there, but just for the simplicity of it. And then we would return t1 plus t2, which works because of iNumber there. But of course, we keep not being complete here. It keeps saying the stuff you're not dealing with because of arrays can be of arbitrary length. So we really need a catch-all. And we can do that. Let's say we do it like this, var t, whoop, that was interesting. Var t, comma, oh, I need the comma up here. And then we want to grab the rest of the list. So we can say dot, dot, and then a pattern, and that gives us whatever's left of whatever list I'm having here. So let's say dot, dot, var rest, and then what we can do is we can take the t and we can add it to add all of the rest. Add all the rest. So that's a recursive implementation. And now, finally, we're complete. We're dealing with all the cases according to the compiler. If I actually took this and moved it up a bit, it would complain, just like with other patterns. It'll check to see, can you even get here? And it'll complain that you can never get here because the previous pattern is already handling everything that could have gotten here, that could have been taken here. So this kind of extra compilation checking is one of the reasons why it's good to use pattern matching. If you had if-elses, you wouldn't get any of that. But now it kind of keeps track of, did you deal with everything? Give you a nice warning if you didn't. only a warning, because it knows what to do if you didn't. It'll just throw an exception. But also, are the places you can't get, and then it will actually flag those as an error. And it does, pattern matching does this already for everything, and we just keep making that work for new kinds of patterns. So we could get rid of this one. It actually deals with it already. And of course, if we move it up one more, the same is the case for the single, and so on. I should also say that you can you don't, the rest doesn't have to be at the end. You could say var t2 here, and put stuff after as well. But you can just have, you can only have one thing of variable length in there, otherwise we wouldn't know where to slice. So I'm not going to do that, but just to show that. Okay? So these can be any pattern. You could also have said, if it starts with, t dot additive identity, then we take this branch here. No, that doesn't work because that's not a constant. But you can put other patterns in here. Var t, sorry. The gist here is that there's now one more recursive pattern in town. It lets you decompose incoming values in a new way. Now, you also have to be a little careful because what does this actually do? What is this rest here? It's an array. And where does that array come from? How does the pattern execute to produce an array that's all the rest? Well, what it does is it calls a slice method. The general idea is that we already have slice methods on a number of types or equivalent behavior. And that's actually already used with the when you index with a range. That's something we added in C#8. So there's a whole there's already a whole pattern pattern in a different sense that the compiler recognizes to see is this thing sliceable? And if it isn't, if it doesn't have the right API on it, well, we won't allow you to do the ... here. But if it is, then we will call that slice method. And the design criterion for those slice methods was they should return the same kind of thing as they're called on. So if you slice an array, you get an array. But slicing an array is expensive. You have to allocate a new array, copy all the elements except one. So maybe this is not the best implementation. Could we still have a recursive implementation? Well, we could, but we just need something else instead of arrays that is cheap to slice. Luckily, we have span of t, which has also been around for a while, and that represents a set of essentially, it's a struct that represents a chunk of memory in such a way that it's just like a start and a length, and so you can cheaply slice it just by creating a new struct that has a smaller range of things. And so now it is actually efficient as well. It's still going to add to the stack. Like before you ask about tail recursion, we don't deal with that yet. I don't know what the problem is here. Let's just compile it and see if I'm just. I don't know why I can't infer the type arguments. But anyway, that's list patterns. So the latest addition to pattern matching, we'll probably keep adding to pattern matching until we feel it's done. But that's the sort of general approach that we are taking nowadays, that we're on a yearly cadence, is how about we try to roll out features little by little? Like there's a limit to how many big features you can dump on people in a yearly release anyway. So either we dump one big feature with every release, which means we have to think it all the way through and we have to anticipate all the scenarios, or we find ways of releasing a feature area little by little, get gradual feedback. We're able to check in with the usage, with the popularity. Is it worth the big investment? What is the next thing that people would really appreciate? And that's what we've done with pattern matching. And we've also done that with other feature areas as well. So unless there's a quick question about this one, I'll move on to the next one. I don't see any. I'm a little nearsighted and it's dark in here, so apologies if I can't see you. OK, on to the next thing. So one of the feature areas that we've gradually been, there are actually several feature areas that we've been rolling out that have to do with declaration and creation of types, making them more flexible in various ways. One of the themes is, why do structs have to suck so much compared to classes? Could they suck a little less? Like, could there be more things they can do that classes can do? So last release, we added struct records after having added class records in C#9. And a few other things along the way. We added the ability to have initializers. And so you can't even have a field initializer in structs before C#10. But whenever we add these features, we keep running into one core issue with structs. And it's been really hard to work around and to find the right design approaches to kind of deal with. And that's the fact that in structs, unlike classes, you can't have a constructor that doesn't initialize everything. If a constructor doesn't initialize everything in a struct, then we give an error, whereas in a class, we would zero initialize everything. And we're like, that's probably very important. That's a very important difference. They did that for a purpose in C#1, and we should not tinker with that. And we kept bumping into it, and we were like, actually, what was the purpose? What was this very important purpose for this? And we couldn't think of one, and we went and asked people who've been there even longer than me. We even asked Anders, who was like the creator of C#, and he said, it seemed right at the time, don't know, can't remember. Well, if we go through so much trouble to detect that you are not initializing a given variable, well, we clearly know that you're not doing it. Could we just do it for you? Could we generate the code instead of just complaining about it? What could possibly go wrong? And the reason I didn't change it to a struct before is simply because I didn't want to show you that the squiggle was gone. So now there's no, the big feature here is there's no error. I didn't want to muck with going back to an earlier version and so on. So you're just going to see the outcome. So there's no error there anymore. And it really sort of opens up the field, no pun intended, in terms of making structs more like classes where it makes sense. Okay, so now we've removed that obstacle, and it'll be easier going forward. One other thing we did recently, let's go back to classes, is we started a push to make object initializers better. Object initializers, a lot of people already use them as an alternative to constructors because constructors are painful. They are very expressive, but they're painful to maintain, very viral. You know, if I were to write a derived class here, public class student, actually, I spell really bad today, don't I? Public class student, that is a person, and we just give it nothing, immediately we're in debt, right? It's already, whoa, you can't use the default constructor, you gotta implement this and that. Now you have to write all this stuff again. You're chaining to the previous one, and so we said, okay, are there more situations where we can avoid that? You know, when you need it, and sometimes you don't have inheritance or whatever, it's nifty, but can we make the alternative better? So we did that by saying, hey, if you just don't have constructors, like you have just a default constructor, and use an object initializer, that should work really well. So let me just go quickly and comment out the other top-level program there, so I can start writing some test code up here. So let's say var mads equals new person, open curly, I can put in a first name equals meds, and immediately I'm in trouble because it was actually an immutable class. And what we did a few releases ago was to say, well, there's a version of the setter that you can use that only works in an object initializer, so I can keep my object immutable once it's created, but I can still mutate it during the object initializer. So that was, again, I think C#9. But there's still some things that are a little annoying here, and one of them is, you know, we also added nullable a couple years ago, and it has a mixed reputation of how good it is to pick up on when things could actually be null. But here it's warning about first name and last name, and it's actually right. It's because what it's saying is you don't have your constructors don't initialize these, and they're null to start with, and they're non-nullable, so they shouldn't be. So what you going to do about it, you know? And the problem up until now was there wasn't really anything I could do about it. I want people to give it first name and last name in the object initializer, but I can't make them. Or can I? So thus was born the idea of required members. I can put required. I don't know what the completion engine is doing, but as I said, preview, internal preview. There you go. These two should be required. This one doesn't have to. It's null, but it's fine because it's nullable. So I'm going to leave that non-required. We could require it if we wanted people to explicitly say null, if we wanted that to be manifest in the creation code, but I've chosen not to. Now I got an error here saying, hey, that's a required member that you didn't initialize. And so it's going to make me do it. All right. I'm going to try to spell it right. And now it's happy, right? So, and what you noticed is that the green squiggles went away down here because now we've told the compiler, don't worry, somebody's going to initialize them. It's going to be in metadata. It's going to make you do it on the other side. So it's happy. You know, it's just like a constructor. We ask them to give a non-nullable value. If they don't do it, they'll get if they give me null, they'll get a warning. But I've done my part. I made sure that it will be initialized. Okay? So that fixes that, and in general, it lets you sort of fine-tune your object initializer experience more. There's one more feature here around properties that I also want to show quickly, and that one isn't in my preview yet. At least it wasn't yesterday, but who knows. But I'll just do it anyway. So auto properties are great, and we've done little things with them over the years, but you know, they have this cliff in them. If you want to do even the tiniest little thing, you know, wafer thin, you fall over the cliff and you have to manually implement your property. If you don't like what the auto property is doing in its accessors, the whole thing falls over. Well, let's fix that. So what we're going to give you in C#11 is that you get access to the backing field of a auto property with a new keyword called field, very, very inventively. So if I want to implement my init accessor here, the standard implementation would be field, escape all the wrong completion here, equals value. Like that's what it does by default. But if I wanted to, you know, just call trim or something, I just want, you know, I just want to clean up the string a little before I put it in. Well, I can do that now. The red squiggle is just because the feature doesn't actually work in this build. And you get to leave one of them auto-implemented and implement the other manually if you want to. Or you can implement both of them yourselves, but if you use the field keyword, it will generate a backing field for you, just like auto properties do today. So even though it's a fully manually implemented property, you can still get the field for free, and you don't have, so you don't have the leakage and the maintenance issue of having the field be available to all the other members in the type and wondering who else is accidentally accessing the field instead of the property and so on. So it's the field is still encapsulated like with an auto prop, but the property itself can get at it. All right? You can see a few places you can use that? Good, good, good. Now for my last trick. I was going to show I want to advertise for a community-based service on the website that's called SharpLab. It's great because you can go and try out the different branches in the C# compiler even as we're making it. But somehow the server isn't working today when I was talking to it an hour ago at least. So I'm not going to use that to show it. Instead, I'm going to let you very briefly into my ugly backup code here, and I'm going to grab this stuff. I'm going to go here. I'm going to delete everything. I'm going to paste it instead. So here's a little program. This last feature is called raw string literals, right? Because those cooked or baked or broiled literals we have today aren't enough. And the point here is that oftentimes you're quoting something in program code directly that is also a form of code. I mean that very broadly. It could be program code in any language. It could be XML or JSON. It could be regular expressions. The point is, it is very likely to have double quotes in it, and it's very likely to have backslashes in it. And even with tool support, making it a little easier to paste that kind of thing into a string literal in C# and get all the extra escapes and whatnot automatically inserted for you, it's still a maintenance nightmare. It's still tough to read and all that. And how about we actually really had string literals that had no escapes in them whatsoever? That's raw string literals. So I have escaped quotes in this content here. If I print it out, you'll know that it'll remove the quotes. I can do it quickly. So there you go. The quotes, not remove the quotes. It will put the quotes and remove the backslashes. Sorry. Good thing I ran it. But if we want it to be raw, then we can put. I don't know why it does that. Preview. We can put triple quotes around it. It couldn't be double quotes because they mean empty string. But triple quotes, that was available. And now if we run it again, what you'll see is that the backslashes are now part of the content. There's no escapes. You can't escape inside of a raw string. So we can just remove the backslashes. Now you're going to say something like, what if I want 3 double quotes in my content? What if I want this? Because now that's going to end this thing. Well, you don't have to put 3 double quotes in front. You have to put at least 3 double quotes in front. And then match it at the end. And so, for some reason, it gave me an extra one there. We really have to work on what the IDE is doing here. So I get my triple quote inside of the content as long as I put more quotes outside. And I know it's a little ridiculous, but it's actually, this is a proven technique in other languages, and it is actually probably the best way that we can think of to, whatever your string literal is, whatever you're copy pasting in, there's a way to defeat it. There's a way to enclose it in such a way that it will become content. So if we run here again, you'll see that the 3 double quotes are in there. Happy times. Now, of course, you want them to be multi-line. Actually, let's go back a little. Let's have the same one here. Okay, you want them to be multi-line. Let's start with just making a single multi-line line. Actually, and that's indented a little, so the code looks nicer. And let's see, that was fine. For some reason that I'll get to soon, we make you, if you put the starting quotes on a separate line, we make you also put the end quotes on a separate line. And now we can go and put it on multiple lines, and something slightly weird is happening in the IDE there, which we'll get back to, but let's just see the output here. Yes, there are multiple lines, but wait! They're flush to the left margin. I did that right. I did it to the right. I always do it wrong, so finally got it. What's going on here? Didn't you say that it was like literal? It was like actually keeping whatever's there. And as far as I can see, there are spaces in front. Well, another thing that really sucks when you're quoting things is that we keep those spaces around always, which means that if you don't want them in your content, you have to put your literals all the way flush to the left in the code, breaking the indentation flow. Some people love that, some people don't. So this obviously is built for the people who don't, but what if I do want it? Well, you see that line here? That's the line that's telling us where the content starts on that line. And if I move the end quote, you can see the line moves. So where the end quote is placed determines how much of the white space in front gets kept. Right? So if I do this, then I get all the white space. And even, if I, let's see, even if I go out here again and I further indent some of it to show internal structure, you can see the line stays in place for the whole literal, and only that space is there. The end quote determines where it is. So that's pretty much it. There's also an interpolation story here, but I'm not going to tell it to you because we're out of time. But it kind of goes along the similar kind of the similar kind of mechanism for making sure that that you can have interpolation and curlies. Curlies can mean interpolation, but you can also defeat it if you want your curlies to be content. Okay? So with that, that's the selection I've chosen to bring here today. Thanks for listening and yelling out corrections when I was doing something stupid. You know, I said internal preview, but most of this is not far behind in public preview. So whenever you use C# in the latest Visual Studio, try saying lang version preview and playing with these new features. And you can start seeing where it works for you, playing with it yourself, just like I did up here. So with that, I want to say thank you very much.